am the founder of ANIL NAIR classes. We are doing a series of conceptual videos on geometry starting from fundamentals. We already did 2 sessions on geometry basics, more specifically from triangles. We will continue with triangles, basic concepts and their application in examination models. Let us straight away get into the concept. Now, I'll just revisit some important key points so that students will not miss out. Triangles. Triangles. Yesterday we discussed, now we will do a different variety of questions. A triangle is nothing but a 3-sided closed figure. A triangle is nothing but a 3-sided closed figure. A 3-sided closed figure is called as a triangle. Suppose if I take 3 lines and connect them and create a closed figure, I will get a triangle. Tri is 3, angle is angles. 3 angles are 3-sided closed figure is called a triangle. So there are 3-sided closed figure. Now opposite to capital A is called the side, which we call it as small a, and this is small b and it is small c. Small c. Right? What is the first proof that we discussed yesterday? Sum of 2 sides. Sum of 2 sides must be greater than third side. Sum of 2 sides must be greater than third side. Sum of 2 sides must be greater than third side. Based upon this one, yesterday we discussed the proof why sum of 2 sides must be greater than third side. Suppose if I take a plus b is greater than c. Let the 2 sides be a and b and the third side be c. If I add c on both the sides, a plus b plus c is greater than c plus c to c. Right? A plus b plus c is nothing but the perimeter. Perimeter is given by 2s, which we will call it by p. P is nothing but a plus b plus c. So perimeter is always greater than 2c. So 2c is less than p. That means c is less than p by 2. C is less than p by 2. Because I took a plus b greater than c, I got c less than p by 2. If I take b plus c greater than a, I will get a less than p by 2. If I take c plus a greater than b, I will get b less than p by 2. Very, very important point. Maximum side or largest side, that is the right usage, largest side integral value is always less than p by 2. Largest side integral value is always less than p by 2. What is p here? P is the perimeter. Today we are going to use this concept in some very, very good tricky problems from triangles. Largest side, if there are 3 sides, if I call it as A, B and C is the largest side, the value of the largest side should always be less than p by 2. Or in other words, the largest side integral value is just less than the integer of the value closer to p by 2. Largest side integral value is always less than p by 2. That is the first concept. What is the next concept? Now let us write down this concept. This I am going to use it in today's class. Largest side integral value. Largest side integral value. Largest side integral value is just less than p by 2. Is just less than p by 2. First concept. Second concept. Now see here. A plus b plus c is equivalent to p. What is p here? P is called the perimeter. P is called the perimeter. P is called the perimeter. Suppose if there are 3 sides, A, B and C. All the 3 sides could be equal, which we call it as an equilateral triangle. 2 sides can be equal, which we call it as an isosceles triangle. All the 3 sides are not equal. If all the 3 sides are not equal, we call it as a scalene triangle. If they are not equal, that means one side will be greater than the other side will be greater than the third side. That means the relationship between 3 sides is always A is greater than or equivalent to B is greater than or equivalent to C. Assuming A as the largest side. Assuming A as the largest side. Now, if you see here, can I say A is the largest side? What is the smallest side? Smallest side is nothing but C. Now, I want the smallest side integral value domain. So, I will make A to C. Can I say A is greater than C? I am substituting instead of A, C. That means value is decreasing. I am substituting B, C instead of B. That means value is decreasing. That means total value will always be less than P. So that means A could also be equivalent to C, B could also be equivalent to C, C will anyway be equivalent to C. That means 3C is less than or equivalent to P. That means C is less than or equivalent to P by 3. C is less than or equivalent to P by 3. What is C here? Smallest side. That means smallest side integral value. Smallest side integral value is always less than or equivalent to P by 3. Is always less than or equivalent to P by 3. Why equivalent to K? Because all the sides can be equal, then we call that triangle as an equilateral triangle. Smallest side integral value is always less than or equivalent to P by 3. That means if there are three sides, the smallest side maximum integral value we can determine, and the largest side maximum integral value we can determine. This slide is extremely important to know the maximum integral values of the smallest side as well as the largest side. I am repeating it again. This slide is extremely important to find out the maximum value of the largest side as well as the smallest side. Largest side maximum integral value you can determine, and the smallest side maximum integral value you can determine based upon this one. Now, few problems we will solve it based upon these two concepts. Every concept whichever I am explaining has got some application attached to it. Largest side maximum integral value and the smallest side maximum integral value. I hope it is clear. Let us solve the first problem. See the first question. All the problems are based on perimeter based problems. See the first one. A triangle has a perimeter of 16. Perimeter is nothing but 16. The two shorter sides, that means there are two shorter sides, their integral values are equivalent to A and A plus 1. A and A plus 1. These are nothing but two shorter sides. Two shorter sides value is given. That means maximum length of the side we don't know. We will call it as x. But there is a relationship between maximum integral value of the largest side and perimeter. What is the maximum integral value? What is the maximum integral value of the largest side? What is the maximum integral value of the largest side? Maximum integral value of the largest side is always less than P by 2. What is P here? P is nothing but the perimeter. Maximum integral value of the largest side is nothing but less than P by 2. What is the P value? P value is 16. That means maximum integral value of the largest side, maximum integral value of the largest side, maximum integral value of the largest side is nothing but less than 16 by 2. It should be 8. The maximum integral value length should be less than 8. Maximum itself, it should be less than 8. Now let us read the question. Which of the following would be the length of the other side? What do you mean by other side? Two sides are given. The other side obviously will be the largest side. What is the condition we got? Largest side maximum integral value should be less than 8. Can it be 8? No, it should be less than 8. First option is eliminated. It should be less than 8. Can it be 10? No, it cannot be 10. Are you all with me? Are you all with me? Now we are stuck between two options 3 and 7 because both are less than 8. Suppose if I take it as 7, if I take it as, suppose if I take it as 3, what is the maximum largest side value? 3. If it is 3, what are the other two sides? A plus 1 plus 3 is nothing but 16. That means A is nothing but 6. So other two sides will be 6 and 7. This is logically incorrect because you are giving 3 as the maximum integral value of the largest side. You are telling that largest side maximum integral value is 3 and you are countering the statement and you are telling that other value is 6 and 7. Maximum value a side can take is 3 but you are taking the value 6 and 7 which is completely non-coherent with each other. That means 3 is incorrect. What is the answer for this question? 7. I hope it is clear. Suppose if it is 7. First is 7. Remaining 2 are nothing but out of 16 one side is 7. Remaining is 9. 9 they both are consecutive numbers 4, 5. 4 is less than 7. 5 is less than 7. That means answer for this question is 7. I hope the concept is clear. What is the concept that is discussed in the first question? The largest side maximum integral value is always less than p by 2. What is p? P is nothing but the perimeter. Maximum integral value a largest side can take is always less than p by 2. This is the concept we discussed. I hope it is clear why 3 is incorrect. If I take 3 beta, 1 is 3, another two values sum will become 13. So 6 and 7. 6, 7 and 3. 3 is the largest value. You are telling largest value it can take is 3, but you are getting 6 and 7. So it cannot be the answer. I hope it is clear, right? Second question. Second one. First one I hope it is clear. Second one. A triangle has a perimeter of 32. Perimeter is given as 32. What is a perimeter? Perimeter is nothing but the sum of the sides. A plus B plus C is nothing but 32. Okay, that is given. What is the second one? The two longer sides. In the previous question he gave two shorter sides. Now there are two longer sides. Two longer sides have integral value. That means if I take three sides of a triangle, previous question he gave two shorter sides. Now he gave two longer sides. What are their values? A and A minus 3. If two longer sides are given, what this will become? This is nothing but the smallest side. What it will become? This will become the smallest side. What is the conclusion that we have drawn? What is the maximum integral value of a smallest side? Maximum integral value. Maximum integral value. Maximum integral value. Maximum integral value of a smallest side. What is the conclusion that we have drawn? Maximum integral value of a smallest side is always less than or equivalent to p by 3. Smallest maximum integral value of a smallest side is always less than or equivalent to p by 3. That means, let me call it as x. X is the smallest side. So this will become less than or equivalent to 32 by 3. 32 by 3 is nothing but 10.66x and everything. That means what should be the smallest side maximum integral value? Maximum integral value is less than or equivalent to 10. So maximum value, maximum integral value of a smallest side, maximum integral value of a smallest side should always be 10. It should always be less than or equivalent to 10. Less than or equivalent to 10. According to the question, which of the following would not be the length of the other side? Value will always be less than or equivalent to 10 point something. It could be 10, it could be 9, it could be 8. Anything less than or equivalent to 10 is possible. That means anything greater than 10 is not possible. Anything less than 10 is possible. Anything less than 10 is possible. Anything less than 10 is possible. Anything greater than 10 is not possible. Question is, which of the following will not be the length. Which value cannot be the length? 11 cannot be the length. Are you all with me? Two beautiful questions which talks about the relationship between the longest side maximum integral value and the smallest side maximum integral value. I am repeating this point again and again because it is of extreme importance to the students. I hope it is clear. Just to make a note of it. Just to make a note of it. Any doubt? Any doubt till now? Two questions which talks about a particular concept. Third question. A lot of questions which we are going to discuss today, all are based on basic fundamentals. We are not going to solve any question which directly uses formula and everything. Most of them are very logical based. I hope it is clear, right? Third question. Third one. Second one, I hope it is clear. Third one. See here. Find the sum of the perimeters of all the triangles. He is asking some triangles are formed. In the triangle, find the perimeter and add all the perimeters of the triangles. Formed from these sides. 8, 20 and x centimeters, where x is an integer. Lowest side is 8, 20 and x. These are the sides of a triangle. Yesterday we discussed one concept. If ABC are the sides of a triangle, what is the condition to get the third side? B minus A less than C less than B plus A to get the right range for the third side. If I use this range, 20 minus 8 less than x less than 20 plus 8. So this is nothing but 12 less than x less than 28. 12 less than x less than 28. I hope it is clear. 12 less than x less than 28. What is the maximum integral value? How many integral values x can take? Total it is 13, 14, 15 and so on up to right 27, which is nothing but total 15 integral values x can take. Total 15 integral values. You can easily check whether it is 15 or not. Number of integral values the third side can take. Number of integral values. Third side can take. It is nothing but the 2 into minimum side value minus 1. We already discussed. So 2 into minimum side value is 8. 2 into 8 minus 1 is 15. So x, the third side can take 15 distinct values. For every one distinct value, I will get one triangle. That means totally there are 15 triangles that are formed with 15 different values for the third side. So he has to find out the perimeter. What are the 15 values? First is 8, 20. Third side will become 13. Next will be 8, 20. Next side will become 14. Next is 8, 20, 15 and so on up to, what is the largest one? 8, 20 and 27. He has to find out the sum of all this one. Total there are 15 distinct triangles that can be formed. That means 15 into something you will get. Answer should be divisible by 15. 456 is not divisible by 15. Let me do the sum. 20 plus 8 is 28 plus 30 is 41. Here it is nothing but 42. 8 plus 20, 28 plus 27 is 55. That means 41 to 55. 41 to 55. Sn is nothing but n by 2 into first term plus last term. First term plus last term. N is total 15. 15 by 2 into What is the lowest? 41, highest is 55. 41 plus 55 is 96. 248, sir. 15 into 48. 15 into 48, I don't need to multiply, is 15 into 50 is 750. Answer is just less than 750, 720. Answer is 720. Another beautiful question which is asking you to find the how many triangles are formed, find the perimeters, add all the values of that perimeters and give me the value. Again I am repeating, two sides are only given, 8, 20, x. If 8, 20, x are the three sides of a triangle, third side value will range from b minus a to b plus a. 20 minus 8 is 12, 20 plus 8 is 28. From 12 to 28 the value will oscillate. From 12 to 28 if the value is oscillating, x will take any value from 13 to 27. 13 to 27 total there are 15 different values. That 15 different values can be obtained directly by doing 2 into minimum side value minus 1. 2 into 8 minus 1, 16 minus 1 is 15. Total there are 15 triangles are formed. So Sn is nothing but n by 2 into first term plus last term. 15 by 2 into 41 plus 55. 15 by 2 into 96. Answer is nothing but 720. I hope question 3 is very clear to you. Question 4. Read the fourth question. ABCD is a rectangle. I hope the audio is clear. Somebody from the back-end team, there are few students who are telling that the voice is not clear. Please take care of my students' request. Please take care of my students' request. Right, we will start the class. Now question number 4. Before we discuss question number 4, let us discuss a concept. Let us discuss a concept. There is a triangle ABC. There is a triangle ABC. O is a point inside the triangle. I will connect this. I will connect this. I will connect this. O is any point. O is any point. O is any point inside the triangle ABC. O is any point inside the triangle ABC. Let me call it as X. Let me call it as Y. Let me call it as Z. D is opposite to capital A is small a. D is nothing but a small b. And it is nothing but a small c. So if I take a triangle AOB, sum of two sides should be greater than third side. X plus Y is greater than C. Similarly, if I take a triangle AOC is nothing but X plus Z greater than B. If I take a triangle BOC,
this video I am going to show you
BOC, Y plus Z is greater than A.
For example,
Y plus Z is greater than A. That means I have got three conditions. X plus Y greater than C, X plus Z greater than B, Y plus Z greater than B. Add this. If I add it, X plus Y plus Y plus Z plus Z plus X, which is 2 into X plus Y plus Z is greater than A plus B plus C. Am I right? That means X plus Y plus Z is greater than A plus B plus C is 2 years. Yes.
And what we're looking for
is extremely important conclusion.
Search.
If O is any point inside the triangle ABC, right? Then the lines drawn from the point to the vertices, their distances X plus Y plus Z is always greater than semi-perimeter. Please make a note of it. This question is based upon that property. X plus Y plus Z is always greater than semi-perimeter. Again I am repeating, I took a triangle ABC, it could be any triangle. O is a point inside the triangle ABC. From O I joined A, from O I joined B, from O I joined C. OA I called it as X, OB I called it as Y, OC I called it as Z.
Under other searches,
If I take triangle AOB, sum of two sides should be greater than third side. X plus Y is greater than C. If I take triangle AOC, X plus Z is greater than B. If I take triangle BOC, Y plus Z is greater than A. If I add all of this, X plus Y plus Z plus X is 2 into X plus Y plus Z greater than A plus B plus C. A plus B plus C is called 2S, 2 got cancelled. That means that line joining from a point inside the triangle to all the three vertices, I will get three distances. Three distances sum is always greater than the semi-perimeter. Perimeter is called 2S, semi-perimeter is called S. Now what I will do is, I will use the same property to join this. ABCD is a rectangle. Okay, if ABCD is a rectangle, that means BD is nothing but
adjust your home page.
BD is nothing but the diagonal. BD is nothing but the diagonal. Okay. BD is nothing but the diagonal. This is nothing but 2 8s are 16. These are nothing but 2 15s are 30. Yesterday we discussed 8, 15, 17 is a Pythagorean triplet. 2 8s are 2 15s are. So this will become 2 17s are. So it is 34. So rectangle diagonal value we got it as 34. Now the same concept, whatever I discussed, the same concept. Let me take a triangle ADP. ADP. If I take a triangle ADP, what is the condition? We got the distances from any point, P is any point, PD plus PA plus PB is greater than semi-perimeter. What is the semi-perimeter we got? 2 8s are 16. 16 plus 30 is 46. 46 plus 34 is 80. 80 semi-perimeter is 40. PD plus PA plus PB. What is PD value? We don't know. What is PA value? 5. What is PB value? We don't know. PD plus PB is greater than 40. That means PD plus PB, it is greater than 35. First condition we got. Similarly, there is another triangle.
This is Udemy, the world's largest marketplace for online learning. On Udemy, I learned ethical hacking and network security.
In DCB, Q is any point inside the triangle, right? So the same condition. What is the condition? QD plus QC plus QB is greater than the, if this is 30, this will also be 30. If this is 16, this is also 16. So it is greater than 40. QD value, it is not given. So QD, it is not given. QB value, it is not given. QC is nothing but 7. So 40 minus 7 is 33. 40 minus 7 is 33. So two values you got. Okay, just 1 minute, sir. I think read the question. Find the minimum integral perimeter of the quadrilateral DBPQ. Quadrilateral perimeter is nothing but the sum of these values. So 35 plus 33 is 68. Minimum integral value greater than 68 is 69. I hope it is clear. I hope it is clear. There was a 1 minute power cut. I think we are back. I hope we are back. I hope it is clear. Idea is clear. Whenever there is a Shiv, please switch off that fan. Right. I hope it is clear. So we took two triangles. One is ABD and another is DBC. So if we added, what is the question? What is the minimum integral value, the integral parameter of quadrilateral DBPQ? Minimum integral value is, what is the integral value just greater than 68? Answer is nothing but 69. I hope the idea is clear. Whenever there is a power interruption, just be patient for 1 minute. We will be switching on it by using backup. Right, so this may happen at times. Kindly cooperate if there is any few seconds of disruption. I hope it is clear. Question number 4, I hope the concept is clear. Idea is to draw a rectangle and understand the concept. If I take any point inside the triangle ABC, the line drawn from the point to the opposite vertex, the distances, the sum is just greater than the semi-perimeter. The sum is just greater than the semi-perimeter. Question number 4, I hope the idea is clear. Question number 5, Balram, this is what you have asked. If the perimeter of a triangle is 14 and the sides are integers, how many different triangles are possible? First we will discuss the traditional method, then we will discuss the direct approach. Method 1, traditional method. Method 1, traditional method. Traditional method. What is a traditional method? Now if you see, a plus b plus c is 14. Maximum integral value. Maximum integral value. Maximum integral value. The largest side can take. Maximum integral value. The largest side can take is just less than p by 2. So 14 by 2, which is 7. What is the maximum integral value a largest side can take? 6. Now I want the minimum integral value. Minimum integral value. Minimum integral value a side can take. Minimum integral value a side can take. Minimum integral value a side can take. How to determine the minimum integral value? A plus b plus c is 14. Minimum integral. For me to get to minimum, remaining 2 should be maximum. So keep the maximum value. 6 plus 6 is 12. So if 6 plus 6 is 12, minimum integral value is nothing but 2. That means maximum integral value is 6 and minimum integral value is 2. Maximum integral value is 6 and minimum integral value is 2. Till here it is clear, right? Just give me 1 minute, sir. After this we will. I hope it is clear. 6, 6, 2. Now first we will discuss the traditional method, then we will discuss the optimal method. 6, 6, 2. Maximum integral value is 6, minimum integral value is 2. So the 6 can go up to 2. 6 plus 2 is 6, 5, 3. The 2 value can increase up to 6. 6, 5, 3. Next is 6, 4, 4. Next is 5, 5, 4. Am I right? All the values, if you see, the minimum integral value a side can take is 2 and the maximum integral value a side can take is 6. So I took the first value 6 plus 6 plus 2. 6 plus 6 plus 2. The value of 6 can go down, right, and the value of 2 can increase. 6 plus 2 is 8. So I did 5 plus 3. 5 plus 5 can still go down. 4 plus 4. If I still go down, 4, it will become 3, 5, 6. 3, 5, 6 and 6, 5, 3. Both are similar, right? If I still go down, I will get the same values in a different order. If I just shift the triangle from one place to another place, the side values will just change. These are the 4 distinct values I will get. So what is the answer for this question? How many distinct triangles are possible? Because the question is different. You cannot take 6, 2, 6. You cannot take 2, 6, 6. Here, because the perimeter value is small, you can directly do this. But what if the perimeter value increases? What if the perimeter becomes a 3-digit number or a 4-digit number? Then the process becomes very, very difficult. That means this method is not the ideal method. There is a famous scientist who gave a direct notation which will help you to derive the answer, right? His name is Manuel, right? We will directly use that one. Right? Please write down method 2. Method 1 is a traditional method, finding out the maximum integral value and the minimum integral value and substituting it. Method 2. Number of distinct method 2. Number of distinct triangles that can be formed. Number of distinct triangles that can be formed with perimeter P. There are two cases that are possible with perimeter P. The first case is P square by 48 nearest integer. P square by 48 nearest integer. This is when P is an even number, or it is P plus 3 whole square divided by 48 when P is an odd number. When P is an even number or when P is an odd number. What is this one? This bracket is nothing but the nearest integral value. This bracket is nothing but the nearest integral value. What do you mean by a nearest integral value? 3.1 is nothing but 3. 3.5 is nothing but 3. 3.6 is nothing but 4. 3.9 is nothing but 4. It is not the greatest integer function or it is not the lowest integer function. It is the nearest integer function. Number of distinct triangles that can be formed with perimeter P is given by a nearest integer function of P square by 48 if P is an even number, or P plus 3 whole square by 48 when P is an odd number. What is the question? If the perimeter of a triangle is 14, if it is 14 is nothing but an even number. If it is an even number, so this will become 14 square by 48, 196 by 48, 196 by 48, 48 3s are 144, 48 4s are 192 point something, 4 point something is nothing but 4. You don't need to find out the maximum integral value of a side or the minimum integral value of a side if you know this concept proposed by a famous mathematician. If a perimeter P is given, number of distinct triangles that can be formed is given by P square by 48. P square by 48 nearest integral value, or P plus 3 whole square by 48 if P is an odd value. Depending upon the numerical value that is given to perimeter, you can use either of this. These P plus 3, we got it plus 3 because of integral solutions. This, when I am discussing the integral solutions from permutation and combinations, right, at that time you will understand every odd number is nothing but 2k1 minus 1. 2k1 minus 1, 2k2 minus 1, 2k3 minus 1. Minus 1, minus 1, minus 1. If it goes to the right hand side, I will get plus 3. That is the reason we got plus 3. I hope the first perimeter, I hope Balram, it is clear. This is the doubt which you asked. I hope it is clear. Next one. Second question. Second one. Question number 5. Question number 6. If the perimeter of a triangle is 77, perimeter is given as 77. What is 77? 77 is an odd number. 77 is an odd number. If it is an odd number, number of distinct triangles. Number of distinct triangles is given by P plus 3 whole square divided by 48. P nearest integer function. 77 plus 3 is 80. 80 whole square is 6400 divided by 48. 6400 divided by 48. 8 6 are 48. 8 800s are 6400. 6 13s are 78. 20. 133.33. Anything less than or equivalent to 0.5, it will take the previous integer. So answer is nothing but 133. If you try to solve by using the maximum length and the minimum length, this problem will become extremely difficult. Perimeter is 33. 33 is an odd number. Number of distinct triangles that can be formed is given by p plus 3 whole square divided by 48. 77 plus 3 is 80. 80 whole square is 6400 divided by 48, which is 133.33. So the lowest integer is nothing but 133. Lowest integer is nothing but 133. I hope it is clear. 16th one. 17th one. This is when the sides are integer. Perimeter odd number, perimeter even number. Now please look at this question. Perimeter odd number and perimeter even number. The sum of the perimeters of all the possible triangles, okay, with the integral sides that can be made having a perimeter of 28 units. That can be, perimeter is 28. Perimeter value is 28. If a perimeter is 28 even or odd number? 28 is an even number. How many distinct triangles are there that can be formed when the perimeter is an even number? Number of distinct triangles that can be formed when perimeter is even number is called the nearest integer function of p plus 3 whole square divided by 48. If this is when the p is an odd number. When p is an even number, here it is an even number. So here it will be p square by 48 when it is an even number. So here it will become 28 square. 28 square divided by 48. 28 square divided by 48, which is nothing but 784 divided by 48. 784 divided by 48. 48 ones are 48. 304. 304. How much it will be? 48 6 are 288. 48 6 are 288. So it goes 16 point something less than 0.5. So I will get number of distinct triangles when the perimeter is even is nothing but the nearest integer function of p square by 48. So I got 16 point something, which is 16. Like that, I will get 16 triangles. Each triangle will have a perimeter of 28. Each triangle will have a perimeter of 28. So he is asking the sum of all the perimeters. 6 8s are 48. Unit digit should be 8. Unit digit should be 8. I hope the idea is clear. If the perimeter is 28, 28 is an even number. If it is an even number, number of distinct triangles that are obtained are given as p square by 48 NIV, nearest integer function. 28 square divided by 48, which is 784 divided by 48, which is 16 point something. 16 point something is nothing but 16. Right, because the value that comes after dot is less than or equivalent to 0.5. 16. There are 16 triangles that are formed. Each triangle will have a perimeter 28. 16 into 28. 6 8s are 48. Unit digit will be 8. Unit digit will be 8. I hope the idea is clear. 448. Students might be struck in solving this 28 square 784. Please write down a logic. These where your speed calculations will be of immensely helpful. Square of the numbers. Square of the numbers till 35. Square of the numbers till 35. Let us do till 25. 35 will automatically come. 21 square is 441. 22 square is 484. 23 square is 529. 24 square is 576. 25 square is 625. 625. Suppose I require 28 square. Step number 1. 28 is 3 units greater than 25. If 28 is 3 units greater than 25, go 3 units below, which is 484. If it is 3 units, add 300. Answer is 784. Answer is 784. If it is 31 square, 31 is 6 units greater than 25. Because 31 is 6 units greater than 25, go 6 units back. 6 units back is 19. 19 square is 361. Because it is 6 units, add 600. I will get 961. If it is 33 square, 33 is 8 units greater than 25. 33 is 8 units greater than 25. Go to 8 units back. 25 minus 8 is 17. 17 square is 289. Because it is 8 units, add 100. So answer is 1089. Answer is 1089. This method we call it as a backtracking method. Backtracking method. This helps you in finding the square till 35. This helps you in finding the squares till 35. What if it is beyond 35? If I find any numerical value, I will discuss. Again, I am repeating it for the second time. If I want 28 square, keep the base, give the center as 25. 28 is 3 units greater than 25. Go 3 units back. 25 minus 3 is 22. 22 square is 484. Because it is 3 units, add 300. 484 plus 300 is nothing but 784. 31 is 6 units greater than 25. 6 units back is 19. 19 square is 361. 6 units means add 600, which is 961. Answer for this question is nothing but 448. 448. I hope it is clear. Question number 7. Question number 8. Number of scalene triangles. Number of scalene triangles with integral sides that can be made with a perimeter of 105 centimeters. Important key point. Important key point. Number of scalene triangles. Number of scalene triangles. Number of scalene triangles with perimeter P. With perimeter P. With perimeter P and integral sides. With perimeter P and integral sides is given by P minus 6 whole square divided by 48. Nearest integer function. This is when P is even. Add 3 to it. P minus 6 plus 3 is P minus 3. P minus 3 whole square divided by 48. Nearest integer function when P is an odd number. When P is an odd number. Please make a note of it. Craig Manuel's key points which we are discussing. Number of scalene triangles. What is the difference between number of triangles and scalene triangles? In triangles there are isosceles triangles. In triangles there are equilateral triangles. In triangles there are scalene triangle. Isosceles plus equilateral plus scalene. It is nothing but total triangles. Total triangles is nothing but total number of scalene plus equilateral plus isosceles. Only scalene triangles is given by the concept P minus 6 whole square by 48 when P is even. P minus 3. It is very easy to deduce this from this. Add 3 to it because every odd number is of the form 2k1 minus 1. There are 3 sides, so it will become minus 3. If it comes to the right hand side, it will become plus 3. What is the value that is given? Perimeter is given as 105 centimeters. Perimeter is 105. 105 is nothing but an odd number. 105 is nothing but an odd number. If it is an odd number, number of scalene triangles, number of scalene triangles with perimeter odd, with perimeter P odd, with perimeter P odd number is given by P minus 3 whole square divided by 48. So these is nothing but nearest integer function. 105 minus 3 is 102 whole square. 102 whole square divided by 48. Divided by 48. 102 whole square is 10404 divided by 48. divided by 48. How to determine 102 whole square as 10404? That also I will discuss. 48 2s are 96. So 80 is remaining. 48 1s are 1. So automatically first two digits I am getting 21. So these all three are out. Answer is nothing but 217. You don't need to find out the values. Just keep an eye on answer option. 102 whole square is 10404 divided by 48. 48 2s are 96, which is 80. 48 1s are 48. 324, 217 point something, you will get it, which is 217. Number of scale and triangles with perimeter P, odd number, is given by P minus 3 whole square divided by 48, nearest integer function. Right? Nearest integer function. Right? I hope it is clear. Just keep an eye on the answer options. If all the values are in the range of closer to 210 and everything, then these finding the square will be helpful. Otherwise, you can play around with the few options. All the options are very far from each other. So you don't need to actually calculate it. Just a little smart observation, you will get the answer. But always, not always answer options will be there in the way which is comfortable to us. Sometimes they might be extreme close to each other. Like if you take a CAT DI paper, till the third digit, till the two digits after dot are similar for few questions. So it is better to know this logic. 102 whole square is 10404 divided by 48. How I got 102 whole square as 10404 directly? Please write down the logic. Students who are not comfortable in square of a number, how to find the square of a number? Directly two questions are enough. It will be very easy for you. How to find the square of a number? To find the square of a number, we use a square minus b square, which is a minus b into a plus b. Minus b square, if it comes to the right hand side, this will be a minus b into a plus b square. This is another beautiful concept that is used to find the square of a number. Suppose if it is 96 square, 96 is nearer to 100. A is 96. B is the difference between 96 and 100, which is 4. 96 minus 4 into 96 plus 4 square, which is 92 into 100 plus 16. Answer is 9216. Similarly, the number we got is 102 whole square. 102 is nearer to 100. 102 minus 2 is 100. 102 plus 2 is 104. Plus 2 square is 4. So answer is 10404. Directly you can deduce the answer if you know this logic of how to find the square of a number using a square minus b square. A square minus b square is a minus b into a plus b. If it is 996 square, answer is 996 minus 4, 996 plus 4 square is 16. Answer is 992016. 992016. In the previous problem, we did how to find the squares till 35. In this problem, how to find the square of a number using a square minus b square. If you know all these speed calculations, it will be very easy for you to determine if the answer options are very close to each other. The only idea is, what is b? B is the difference between number and assumed base. B is the difference between number and assumed base. B is the difference between number and assumed base. B is the difference between number and assumed base. I hope question number 8 is clear. You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.